Hello and welcome to CalSort podcast series. This is your host Umang Rajvanshi, and today we are going to cover a very interesting topic on how ONAP can be used for edge computing. To those who are new to ONAP, ONAP stands for Open Network Automation Platform. It is an open source NFV solution coming from the likes of AT&T to provide end-to-end telco automation. Given their subscriber base a strong foothold in the market, a solution from AT&T certainly designed to address real-world use cases. ONAP is a comprehensive platform, right from designing network services to managing complete lifecycle of virtual network functions to doing closed-loop automation. All of this can be done with the help of ONAP. So today we have Pawan Gupta with us. Pawan is a telco architect at CalSoft and has more than 18 years of experience in building and promoting products in wireless, telecom and networking domain. Welcome Pawan.
Thank you, Aman.
Along with us is Amar Kapadia from Arna Networks. Arna Networks is an open source startup and strongly focused on ONAP. Amar is the founder of the company and he is a strong proponent of open source technologies. He was earlier senior director of product management at Mirantis, which is an open source OpenStack company. Amar has a deep understanding of how open source technologies can be adopted for real world use cases and he understands the dynamics of business behind it. In the past, he has successfully led a startup, Arohi Communications, which was acquired by Emulex. Welcome for the podcast, Amar.
Thanks, Umar. Delighted to be here.
It's a privilege to host you both here. So, Pawan, let's start with our first question on ONAP.
So before I get started with the questions, I'd like to point out that ONAP is traditionally being considered for NFV workload automation, and it sort of leverages the SDN technology for that. But in this podcast, we will cover a slightly different angle of ONAP, and that is understand how it can be used for automation of edge computing workloads. So with that, let me start with the first question. The very essence of edge computing is to host your content right at the radio access terminal or process the data right next to the radio tower. And when you have this, you can reduce the latency to respond to the network device. And when you can actually respond to the network device in less than 10 milliseconds, the latency issue is taken care of, and actually opens up a lot of real world use cases like connected cars, healthcare, IoT, gaming. So it's a whole new set of opportunities that can be addressed when the latency is less. Can you please help us understand the readiness of ONAP when it comes to edge computing?
Okay, that's a great question, Pawan. As you rightly said, the low latency of edge computing is one of its greatest attributes. And one of the most salient examples of that a lot of people might have heard of is AR or VR, augmented reality, virtual reality. But in addition to that, there are other use cases like remote surgery in the case of healthcare, or in industrial, where some of the machines are very latency sensitive, and the only way they'll move from wired to wireless is with low latency. So having said all of that, ONAP is in the control and management plane. So ONAP itself does not contribute to low latency per se, but ONAP is critical when it comes to edge computing because it provides three key functions that are required for workloads that reside on the edge. First, orchestration of edge workloads. Second, ongoing lifecycle management. And third is monitoring and closed loop automation. So over the discussion, I'm sure we'll discuss some of these attributes. But when it comes specifically to latency, what you can do is you can attach latency policies or latency attributes to a specific workload or portion of a workload, and ONAP has the smarts to orchestrate it to the right location. So if it's a low latency application, of course, it'll be orchestrated to an edge. If it's a application where you don't care about latency, but instead perhaps you care about cost, then it'll be orchestrated into a centralized cloud or a public cloud.
Okay, okay. So that's quite interesting. So basically, you can provide the policies in ONAP to decide, where the application has to be deployed, either on the edge or in the central cloud, and ONAP is able to handle, such use cases.
That's right. That's right.
Okay, and when you talk about the management and control plane, certainly, you want to have the overheads for the management plane also reduced. You know, does ONAP have any, fine tuning of, doing the management of the entire system, from edge computing perspective?
Yes. So what you have with edge computing is even the management has to be distributed, because certain aspects of management have to be on the edge. So not only is the managed workload on the edge, but certain aspects of management also have to be on the edge, like data collection, maybe some data analysis. And then you have management that's centralized. So ONAP certainly supports this. There are aspects of ONAP that get orchestrated to the edge, specifically, as we discussed, monitoring, data analysis, etc. But then most of ONAP is, of course, centralized. And ONAP is modular. So depending on what you need, you can choose what aspects of ONAP to deploy centrally. And a lot of the pieces that are orchestrated onto the edge from an ONAP point of view, so pieces of ONAP that are deployed, we are not talking about workloads now, are also orchestrated on demand. So for example, if there is no need for a certain analytics application, like let's say threshold checking, then it's not going to get orchestrated to the edge. If it's needed, it'll get orchestrated. So these are some of the ways that you can be very conscious about the footprint, because as we know, edge is extremely constrained, and we definitely don't want to put more bits than are absolutely required.
Yeah. Okay. Okay. Oh, so that's good to know actually. So, it's inherently supporting edge computing. That's what I understand from you. You talked about the constraints that edge computing has, and my next question is based on that. So, edge data centers, which are next to the radio access terminal, so you would have a small data center right beside the radio tower, or maybe in close proximity of it. So these data centers will have a very small form factor compared to your regular ones, and the scaling these data centers is going to be a challenge because there is going to be limited physical space available, and also the physical access may not be that great. You typically don't have too many people accessing the radio tower areas. So clearly the infrastructure that is provided in these edge data center have to be optimally used. And one of the things I see when it comes to compute infrastructure is, the workloads are run in virtual machines, but given the overhead of virtual machines, it is likely that your applications, edge applications, and workloads, like you say, would be run in containers. And because they're just very lightweight and have very few overhead, so the compute resources would be less strained when you use containers to run the applications. Can you please help us understand, what is the support ONAP has at present to deploy and manage containers on edge nodes?
Yes, of course. ONAP supports containerized applications. It might be useful to go through the history of ONAP a little bit to answer this question more completely. ONAP started off supporting NFV and SDN services. And since that world was almost entirely virtual machines, that's how ONAP started, supporting virtual machines, specifically with OpenStack. But as of the Dublin release, ONAP now supports containerized applications, more specifically Kubernetes applications. So if you imagine you have thousands of Kubernetes edge clouds, ONAP can now take applications and push them to the right edge clouds, manage their lifecycle, and terminate them. So two things have happened now because of this shift to containerized. First, ONAP can support not only CNFs, container cloud native network functions, but it can also support analytics applications. It can support arbitrary cloud native applications like AR/VR or 360 video. So that's one side effect. The other way the footprint gets reduced, of course, containers, as we know, are much lighter weight than virtual machines, as you pointed out, Pawan. But the other aspect which contributes to a lightweight footprint on the edge is the ability to do full lifecycle management, including termination. So termination normally is not done in cloud applications. You just install whatever applications you need on the cloud and they sit there for a long time. On the edge, you have to remove them as soon as nobody is using them and free up the space for something else, because there will always be more applications that you need to run on the edge than the edge resources available. So those are some of the ways ONAP is particularly suited to the edge in terms of supporting cloud native containerized applications and managing the full life cycle and keeping the applications dynamic.
Okay, so I think that's pretty good to know that there is support for Kubernetes and doing the complete life cycle management of containers in ONAP. So when you say the complete life cycle management of containerized applications, so can you do onboarding of these applications and deploy them inherently using Kubernetes onto the edge servers? All of this can be achieved with ONAP. That's what you mean, correct?
Correct. So step one, you onboard applications onto ONAP into the design palette of ONAP. Step two, those applications get orchestrated to the right edge clouds. Step three, you do ongoing lifecycle management. Step four, you do monitoring with closed loop automation as required, real-time policy-driven closed loop automation to be more specific as required. Now I will point out that the support for containerized applications in ONAP is early, and there is no official onboarding spec yet. For virtual machines, so for VNFs, etc., there's a very well-written and comprehensive packaging specification for onboarding. That is not the case yet for containerized applications, but my expectation is that you will see that coming in 2020 or so. So for now, the specification is somewhat ad hoc, but it should get formalized next year.
Okay. So we need to kind of wait for some time till we have the complete workflow for containerized application supported in ONAP.
For widespread mainstream adoption, I would say it's ready for testing, development, POCs. So that we need not wait for that.
Okay, good to know that. So, with edge computing, you're going to have hundreds of or even thousands of edge nodes, and all of these would be centrally managed, and you can potentially do that with ONAP. So I presume, ONAP has a centralized dashboard where you can completely take a control of all these edge nodes that are hosting various applications. Is that correct?
Yeah, ONAP certainly allows you to have centralized control over hundreds, thousands, tens of thousands of edge clouds and the ability to orchestrate applications onto them. And with edge, we will see the idea of N-tier applications. So in the cloud world, you typically had 3-tier. But here you will have N-tier, where bits of the software are on the edge, bits are at the aggregation, some portions are at the core, and others are in the public cloud. Pieces may be replicated across edges. So ONAP can do all of that. Now, when it comes to a dashboard, that I'm not so sure I would say there's a dashboard. ONAP's whole methodology is model-driven. So once you create models for your application and you attach policies to the various subcomponents or sub-services of an overall service or an application. They will get orchestrated to the right place, and you will be able to monitor them using APIs. Dashboards may have to be developed for your specific use case.
Oh, okay. So that's an opportunity for companies like Arna to add value to ONAP, I believe, I'm sure, potential ONAP users would sort of like to have a central monitoring mechanism and want to see the status of all their applications running. So this is sort of a value add-on for people who want to work in ONAP, who want to kind of create additional features in that area.
That's exactly right. ONAP itself is a platform, and a lot of the applications, artifacts, and dashboards that sit on top, some exist in the community, others will have to be developed. So that is an opportunity, as you rightly point out.
Okay. All right. And when you're talking about the scale of hundreds and thousands of servers, running at the edge nodes, things are bound to go wrong. A server might fail. Software applications may not perform correctly. They might crash. There could be software issues, software crashes, and clearly, you don't want somebody to physically go and fix the issues. That's going to be quite a task when you're talking of the scale. What support does ONAP have when it comes to addressing these failures? You talked about closed loop automation. Is there any self-healing mechanism available in ONAP that you can leverage?
So you bring up a very important point, Pavan. When you have tens of thousands of edge clouds, you cannot have a human being fixing issues. In the edge environment, I sort of view it as a two-tier way of handling failures. The first tier is Kubernetes itself. So as we move from OpenStack to Kubernetes, we get richer functionality. So Kubernetes has the ability to self-heal. It has the ability to create a new replica should another replica fail. So there is some level of resilience built in at the Kubernetes level. However, that's not enough. For example, if you're having a performance issue, Kubernetes doesn't know there's a performance issue going on. Or if there is dependencies where there are failures that are dependent on each other, again, Kubernetes doesn't have the notion that these two applications or services depend on each other. Or if there is something going on between clusters. So it's a coordination between the two layers. Now, ONAP itself, there is no concept of self-healing per se, but all of the application and infrastructure telemetry goes to ONAP. So whether they're events, alarms, logs, SNMP data, files, whatever you have goes to ONAP. That gets run through an analytics pipeline. The result of that analytics pipeline goes to a policy engine, and then the policy engine drives either the orchestration engine or one of its controllers to take an appropriate lifecycle management action. So in some sense, yes, there is healing built in, but those healing rules and applications have to be developed either by the community or by the user.
Okay, all right. So again, this is an area where people can add more value to the ONAP community, and then companies like Arna can also pitch in by providing these features that operators would love to have.
Exactly. Both of our companies, so Arna, it's an opportunity for CalSoft as well to provide some interesting services. So I think this is a good area, good opportunity to add value.
Okay. So ONAP has inbuilt use cases from a demo perspective. So if you want to really understand how NFV works, and how VNF lifecycle management is done, there are certain use cases built into ONAP distribution. Is there anything specific to edge computing that is available at present in ONAP, which you can use to experiment, understand, and try out?
Yes, it is available. But interestingly, the use case is available in the Linux Foundation Edge Akraino community and not ONAP per se. ONAP does have an edge computing work, but that has not produced a blueprint yet. But instead, if you go to the Linux Foundation Edge Akraino project, there is a blueprint called Integrated Cloud Native, ICN. And that blueprint shows you exactly how to use ONAP with Kubernetes to deploy a variety of edge applications. And that blueprint has a 360-degree video application. It has Edgex Foundry for IoT. It has an analytics application. And finally, it has network functions for SD-WAN. So if there are users listening to this podcast that want to try out ONAP for edge computing, then I would point them to that Akraino blueprint.
Oh, that's actually interesting. So if you take that blueprint and you deploy it, then you can actually be able to get an experience of an edge computing use case with all the desired components running. And I presume you can do that in a matter of hours, because blueprint is ready. Correct me if I'm wrong.
The blueprint is actually in development, so they can see what has been done so far. And of course, it's an open community, so users, vendors, individuals can join and start participating. So what you said is a true statement when the blueprint is complete. So that I don't have an exact number, but I believe in a few months it will be ready. And at that point, within a matter of few hours, people will be able to try out exactly what you mentioned.
Oh, okay, great. And any plans for RADA networks with your ONAP distribution to support edge computing use cases or features? Do you have something in your pipeline?
Yes, in fact, edge computing is a key area of focus for us. We believe that with edge, you get new environments like Kubernetes, you get disaggregation, and ONAP is particularly well suited for that environment. And we also believe that the first edge computing use case will be 5G, and ONAP is also particularly well suited to 5G with the whole real-time policy-driven closed-loop automation engine, which can be helpful for network slicing. It can be helpful for radio optimization. So all in all, we believe that that's, at least from our standpoint, that's the most attractive use case, edge computing, and with a sub-use case of 5G.
Okay, all right. And one more question I have, Amar, is, with all these containerized applications or virtual machines running in the edge nodes, or maybe in the public cloud, and they're talking to each other. So there's going to be a lot of networking happening, between these applications. Certainly would be talking to each other. There needs to be support for networking, and I presume that that's going to be virtual networking, which would be used to support these applications talk to each other. Is there any support in ONAP when it comes to networking of the edge applications?
Yes. In fact, I would say that's maybe one of ONAP's strong points. So as we discussed when we went through the history of ONAP, it was originally really designed for NFV and SDN services. And only recently it has become suitable for edge applications. And you see a variety of end users and vendors using ONAP for edge applications. So given that the history is primarily NFV and SDN, it has very strong support for networking. ONAP can definitely talk to southbound SDN controllers or SD-WAN controllers if you want to connect different data centers, edge sites to core sites, etc. In fact, ONAP even has an inbuilt SDN controller. It's Open Daylight, and it's been supplemented with a directed graph capability. So that gives you a lot of flexibility in terms of how you can plumb networks between data centers. And finally, you can design NFV services using VNFs connected over virtual networks. So you can design that whole service in ONAP, and it gets pushed down to either Kubernetes or OpenStack. Of course, the virtual network is taken care of by the underlying layer, OpenStack or Kubernetes. ONAP doesn't do that per se, but that construct can be created in ONAP and pushed down to the appropriate clouds. So I would say networking is a very critical piece. So you rightly point out that this is very important. And I think some of the other orchestrators that are coming from a different point of view will struggle on this point. And ONAP is uniquely differentiated to address this.
Okay, so basically, you have the flexibility to choose your virtual networking solution. Like you might want to go with Tungsten Fabric or Neutron networking, NSX networking, Calico, Flannel. I mean, these are the sort of the latest trends when it comes to virtual networking, and you can leverage all of this with ONAP, because at the top layer it uses OpenStack or Kubernetes APIs, and later on, they can hook to these different virtual networking solutions to create the underlying switches and routers that you need to support for VNFs and CNFs.
That's correct. That's exactly correct.
Okay. All right. Amar, you must have been talking to a lot of potential customers pitching ONAP for orchestrating their workloads. I would like to get a sense of the market. What do you think the feedback is like? How's the adoption of ONAP happening in the industry? Are the customers asking for something very specific things or use cases to be supported? Can you shed some light or whatever you can?
Yeah, absolutely. So let's delineate the more traditional NFV and SDN use cases with respect to edge use cases. So ONAP today is already getting traction in the more traditional NFV and SDN use cases, given that that's where ONAP came from. And it's public data, so you can see it. AT&T has put ONAP in production for certain use cases. This is in addition to ECOM. They have ECOM, which was the predecessor to ONAP, and that's proprietary AT&T technology. That, of course, has been in production for a while, but ONAP is also in production for certain use cases. Orange has put it into ONAP into production, and so has Bell Canada for certain use cases. Now, when we come to Edge, ONAP is not in production for Edge, I would say. And that's because the Edge itself is so new, and I don't believe there are many Edge sites in production. Having said that, I believe that you will see a progression of ONAP being used sometime next year, initially for 5G, because you can view RAN, Virtual Radio Area Network, as an edge application. So once 5G starts to roll out, you will see that being the first edge application. And then after that, we will see analytics applications, so the need to do inference engines at the edge. You will start to see consumer style applications like AR, VR, etc. So that is how I see ONAP progressing for the edge.
So you think, sometime late 2020 is when some real world use cases of edge computing would sort of see the light, when it comes to use of ONAP?
That's right. That's right. I think it'll be second half of 2020. And I just maybe want to make one point just to make sure the audience doesn't get confused. Of course, Edge is out there. Edge is being deployed. I think the comments I made earlier were Edge in combination with ONAP.
All right. One more question is about security. That's going to be very critical. Again, we're talking about very large scale when it comes to edge computing. And, security is going to be very critical for operators. What support does ONAP have when it comes to securing your edge deployments and edge applications?
So that's a really good question, because these days security is of paramount importance. So as we discussed in the first question, ONAP is primarily management and control path. So most of the burden of security is on the network functions and applications that will be consumer facing. Having said that, there are a lot of security policies that have to be pushed to a particular edge along with the application. And additionally, you also have to push a lot of secrets that go along with an application edge application. All of that orchestration will be done by ONAP. So security policies, secrets themselves will all be orchestrated by ONAP along with the application. Additionally, ONAP itself has to be secure also. So even though ONAP is not, no user is going to deal directly with ONAP, it is an important piece of the overall service, and it has to be secure. So there's a specific security subcommittee in the ONAP overall community, and that subcommittee is responsible for vulnerability scanning, security best practices, etc., to make sure that ONAP as a piece of software itself is secure. So I think by virtue of those two, one, by making sure that ONAP itself is a secure piece of software, and B, by using ONAP to push security policies and secrets to the edge along with the application, that is how ONAP will contribute to edge security.
Okay, and I believe there are tools like Istio which are used for container security. Those can also be used with ONAP. My guess is that, right?
Actually, thanks for pointing that out because I missed that point. Yes, ONAP can not only orchestrate applications, ONAP can also orchestrate things like network service mesh, like Istio, to go along with the application, because as we know, something like Istio can really enhance the security of applications. So that's at one level. And second, Istio is also being integrated with ONAP itself to further increase the security instrumentation of ONAP.
Oh, okay. So I think there is a lot of work happening by the ONAP community to ensure security, and that's good to know because that's going to be one of the critical factors when operators decide to use ONAP. Finally, Amar, I want to ask you a question, and that is, how can people try out ONAP? I understand open source takes a lot of time to get it running. You have it completely functional and where you can get your hands dirty. What are your suggestions? Is there something that people leverage from Arna networks to get started with ONAP?
Yes. So users, of course, you can go to docs.onap.org, and that's a good place to start. But as you point out, Pavan, many times if you go to just the pure open source, it can take you several weeks to get the software up and running. So to make that process easy, we have our own distribution, Arna Networks ONAP distribution, Anode. Currently, we are shipping 3.0, which is based on the Dublin release. And there we have an enhanced version of the installer. And with that, we have found that users are able to cut the 3 to 4 weeks down to about half a day.
Oh, that's amazing, actually. And then they can do this on a public cloud, or they need to do it on their own private cloud. How does it work?
So they can do it on either. They can do it on Google Cloud Platform, and that is a free trial, so there is no cost for doing that. Or users can do it on-prem, in which case there is a support cost. And both avenues are open. And along with that, we also help with things like deployment. So we have some deployment services, and we also offer training. So we offer a number of ways for users to get themselves jump-started on ONAP.
Oh, thanks for letting know, Amar. I think that's very useful. If you have something available on the public cloud, like the Google Cloud, and if people can use the installer to get things running up in just a matter of hours, then I think that's a great thing for people understand ONAP, understand how it can be used for NFE, SDN, and edge computing use cases. Thanks for those efforts, Amar. That's all I have for this podcast. I think what you have shared is amazing insights in ONAP, and I believe the audience would find them very useful when they consider ONAP for use in edge computing use cases. And one last comment is, please, if you want to try out ONAP, try out the Google Cloud Anode distribution. That's free of cost, and you can run ONAP there and get a feel of how it works. Umang, over to you.
So thanks, Amar. Thanks, Pawan, for the wonderful podcast. So with this, we would like to sign off for today. Thanks for tuning in. For any questions, please write to us at marketing@calsoutinc.com and amar@arnanetworks.com, and stay tuned for our future podcasts. Thank you. Thanks, Amar.
Thank you so much. Thanks, Pawan. This has been really enjoyable, and thanks, Umang, for the opportunity.
Thank you.